Next, I'm going to keep my IP address the same, but I'm going to change my mask to a /30. So if I were to ask you, what would the mask look like in dotted decimal? Of course, /30 is more than 24 bits. So you know the first 3 octets, which is 8 bits, 8 bits, and 8 bits, the mask is going to be 255.255.255 dot something. So I'm going to draw out the last octet, /30. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 4, 8, 16, 32, 64, and 128. So the first, second, and third octet make 24 bits. 8 plus 8 plus 8 is 24. And I have to get to the number 30. 25, 26, 27, 28, 29, 30. 128 plus 64 plus 32 plus 16 plus 8 plus 4 gives me 252. So the mask would become 255.255.252. Now if you notice, the value of the last bit turned on here is 4. So you start at 150, 101, 45.0/30. My next street over, or my next network, starts at 150, 101, 45.4/30. My next one will start at 150, 101, 45. Add 4 to 4, you get 8. I'm just making jumps of 4. My next one would start at 150, 101, 45.12/30. The valid addresses over here in the first network would be .1 and .2. .3 would be my broadcast. Again, in the next street over, my house numbers would be .5 and .6. .7 again would be broadcast. My next street over, my valid addresses are going to be .9 and .10. .11 would be my broadcast. The point I'm getting at is that with a /30 mask, you only get 2 addresses. So a /30 mask or a 255.255.252 mask should always be used over point-to-point links. So if you have router 1 on this side and router 2 on this side, one address goes here and one address goes here. So over point-to-point links, that could be on the exam, you always use a /30 or a 252 mask. Otherwise, you're wasting addresses. You only need 2 addresses, one on each side. Any other mask, like a /29 mask, would yield 6 addresses, and you're wasting 4. And as you guys notice, I'm not even playing with the IP. I'm simply playing with the mask. Let's make this /19, and let's make this 64.0. My question to you guys, or a question could be, what is the valid host range for this network? Well, let's figure it out. Again, I'm going to take the subnet mask, which is /19, and break it down into binary. So this time I'll do the whole thing. 1, 2, 3, 4, 5, 6, 7, 8. Dot 1, 2, 3, 4, 5, 6, 7, 8. Dot 1, 2, 3, 4, 5, 6, 7, 8. Dot 1, 2, 3, 4, 5, 6, 7, 8. So are we working in the first octet, second octet, third octet, or fourth octet? Let's find out. 19 bits turned on. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. I'm working in the third octet. The rest of the bits are off. What is the value of the last bit turned on? Let's find out. 1, 2, 4, 8, 16, 32, 64, 128. So the value of the last bit turned on is 32. So we have found out that the value of the last bit turned on is 32. 128 plus 64 plus 32 is 224. So this is 224. The first octet, everything's on, so it is 255. Second octet is 255. Third octet is 224. The last octet, everything is off, so it's simply 0. So I'm going to go ahead and erase this because I need the space. Just remember that the value of the last bit turned on was 32. So the mask will be 255, 255. In dotted decimal, it would be 255, 255, 224.0. You start at 150, 101, 0.0 slash 19. What was the value of the last bit turned on? It was 32. And I'm looking for the 64 network. So my first street started at 150, 101, 0.0. My next street will start at, I should write this a little bit higher. So my first street started at 150, 101, 0.0 slash 19. My next network or street is, we're working in the third octet, remember, 150, 101, and I simply add 32, since the value of the last bit turned on was 32. 32.0 slash 19. My next network would be 150, 101, 64.0 slash 19. My next network would be 150, 101, 96. I just simply add 32 to 64 to yield 96.0 slash 19. So I had asked, what is the valid host range for this network? Well, the first address would be 64.1. The last possible address for this street would be one before the next street. Since the next street starts at 96, it would be 95.255. 95.254 would be my last valid address. 95.255, as always, being my broadcast. So my valid range would be 64.1 through 95.254. Not hard, guys. As long as you remember the rule, you look at the value of the last bit turned on, and then that gives you the block size. Then you start at 0 in that octet and keep adding that number till you get to your relevant network that you're trying to find the range for. Okay, I'm going to go ahead and erase the board. We will do one more example question, and then we will move on.